Let us now look at the case clause, which allows us to apply conditional logic in SQL. So you can see here a simple query. I am getting the data from the characters table. I am filtering it so that we only look at characters who are alive, and then for each character we're getting the name and the level. Now, when you have a column that contains numbers such as level, one typical thing that you do in data analysis is bucketing. And bucketing basically means that I look at all these multiple values that level can have and I reduce them to a smaller number of values so that whoever looks at the data can make sense of it more easily. Now, the simplest form of bucketing that you can have is the one that has only two buckets, right? So looking at level, our two buckets, for example, could be in one bucket we put values that are equal or bigger than 20, so characters who have a level that's at least 20, and in the other bucket we put all the characters that have a level that is less than 20, for example. Now, how could I define those two buckets? So we know that we can define new columns in the select statement and that we can use calculations and logical statements to define those columns. So one thing that I could do would be to go here and then write level bigger or equal than 20. And then call this new column level at least 20, for example. And when I run this, I get my column. Now, of course, this is a logical statement, and for each row, this will be true or false. And then you can see that our new column here gives us true or false on every column. And this is a really basic form of bucketing because it allows us to take, level has basically 11 different values in our data, and it can be complicated to look at this many values at once. And now we've taken these 11 values and reduced them to two buckets so that we have organized our data better and it's easier to read. But there are two limitations with this approach. One, I might not want to call my buckets true or false. I might want to give more informative names to my buckets, such as experienced or inexperienced, for example. The other limitation is that with this approach, I can effectively only divide my data in two buckets, because once I write a logical statement, it's either true or false, so my data gets divided in two. But often it's the case that I want to use multiple buckets for my use case. Now, bucketing is a typical use case for the case when statement, so let's see it in action now. So let me first write a comment, not any actual code, where I define what I want to do, and then I will do it with the code. So I have written here the buckets that I want to use to classify the character's level. So up to 15, they are considered low experience. Between 15 and 25, they are considered mid, and anything above 25, we will classify as super. Now let us apply the case clause to make this work. So the case clause is always bookended by these two parts, case and end. So it starts with case, it ends with end, and a typical error when you're getting started is to forget about the end part. So my recommendation is to always start by writing both of these and then going in the middle to write the rest. Now in the middle, we're going to define all the conditions that we're interested in, and each condition starts with the keyword when and is then followed by a logical condition. So our logical condition here is level smaller than 15. Now we have to define what to do when this condition is true, and it follows with the keyword then, And when this condition is true, we want to return the value low, which is a string, a piece of text that says low. Next, we proceed with the following condition. So when level is bigger and equal to 15 and level is lower than 25. So if you have trouble understanding this logical statement, I suggest you go back to the lecture about Boolean algebra. But what we have here, there are two microstatements, right? Level under 25 and level equal or bigger than 15. They are connected by AND, which means that both of these statements have to be true in order for the whole statement to be true, which is what we want in this case, right? And what do we want to return in this case? We will return the value mid. And the last condition that we want to apply, when level is bigger or equal than 25, then we will return super. Now, all of this that you see here, this is the case clause, right? Or the case statement. And all of this is basically defining a new column in my table. And given that it's a new column, I can use the aliasing to also give it a name. And I can call this level bucket. Now let's run this and see what we get. And as you can see, we have our level bucket, and the characters that are above 25 are super, and then we have a few mids, and then everyone who's under 15 is low. So we got the results we wanted, and now let us see exactly how the case statement works. So I'm going to take Gandalf over here, and he has level 30. So I'm going to write over here level equals 30 because we're looking at the first row, and that is the value of level. And then I'm going to take the conditions for the case statement that we are examining and add them here as a comment. Now, because in our first row level equals 30, I'm going to take the value and substitute it here for level. Now what we have here is a sequence of logical statements, and we have seen how to work with these logical statements in the lecture on Boolean algebra. Now our job is to go through each of these logical statements in turn and evaluate them, and then as soon as we find one that's true, we will stop. So the first one is 30 smaller than 15. Now this is false, so we continue. The second one is a more complex statement. We have 30 greater or equal to 15, which is actually true, and 30, oops, I did not substitute it there, but I will do it now, and 30 smaller than 25, which is false. And we know from our Boolean algebra that true and false evaluates to false. Therefore, the second statement is also false, so we continue. And now we have 30 greater or equal than 25, which is true, so we finally found a line which evaluates as true, and that means that we return the value super. And as you can see for Gandalf, we have indeed gotten the value super. Let us look very quickly at one more example. We get Legolas, which is level 22. And so I will once again copy this whole thing and comment it. And I will substitute 22 for every value of level because that's the row we're looking at. And then looking at the first row, 22 smaller than 15 is false. So we proceed. And then looking at the second row, 22 bigger than 15 is true, and 22 smaller than 25 is also true, so we get true and true, which evaluates to true, and so we return mid. And then looking at Legolas, we get mid. So this is how the case when statement works in short. For each row, you insert the values that correspond to your row, in this case, the value of level, and then you evaluate each of these logical conditions in turn, and as soon as one of them returns true, then you return the value that corresponds to that condition, and then you move on to the next row. Now I will clean this up a bit. And now looking at this statement now and knowing what we know about the way it works, can we think of a way to optimize it, to make it nicer, to remove redundancies? Think about it for a minute. Now, one thing we could do to improve it is to remove this little bit over here, because if you think about it, this part that I've highlighted is making sure that the character is not under 15, so that it can be classified as mid. But actually, we already have the first condition that makes sure that if the character is under 15, then the statement will output low and then move on. So if the character is under 15, we will never end up in the second statement. But if we do end up in the second statement, we already know that the character is not under 15. This is due to the fact that case when proceeds condition by condition and exits as soon as a condition is true. So effectively, I can remove this part over here, and then at the second condition, only make sure that the level is below 25, and you will see if you run this that our bucketing system works just the same. And the other improvement that I can add is to replace this last line with an else clause. So the else clause takes care of all the cases that did not meet any of the conditions that we specified. So the case statement will go condition by condition and look for a condition that's true, but in the end, if none of the conditions were true, it will return what the else clause says. So it's like a fallback for the cases when none of our conditions turned out to be true. And if you look at our logic, you will see that if this has returned false and this has returned false, all that's left is characters that have a level which is either 25 or bigger than 25. So it is sufficient to use an else and to call those super. And if I run this, you will see that our bucketing works just the same. For example, Gandalf is still marked as super because in the case of Gandalf, this condition has returned false and this condition has returned false, and so the else output has been written there. Now, what do you think would happen if I completely removed the else? What do you think would happen if I only had two conditions, but it can be the case that none of them is true? What will SQL do in that case? Let us try it and see what happens. So the typical response in SQL when it doesn't know what to do is to select a null value, right? And if you think about it, it makes sense because we have specified what happens when level is below 15 and when level is below 25, but none of these are true, and we haven't specified what we want to do when none of these are true. And because we have been silent on this issue, SQL has no choice but to put a null value in there. So this is practically equivalent to saying else null. This is the default behavior for SQL when you don't specify an else clause. Now, like every other piece of SQL, the case statement is quite flexible. For instance, you are not forced to always create a text column out of it. You can also create an integer column, so you could define a simpler leveling system for your characters by using 1 and 2, else 3 for the higher level characters. And this of course will also work, as you can see here. However, one thing that you cannot do is to mix types, right? Because what this does is that it results in one column, in a new column. And as you know, in SQL, you are not allowed to mix types between columns. So always keep it consistent when it comes to typing. And then when it comes to writing the when condition, all the computational power of SQL is available. So you can reference columns that you are not selecting. You can run calculations as I am doing here, and you can chain logical statements, right? Boolean statements in complex ways. You can really do anything you want. Although I generally suggest to keep it as simple as possible for your sake and the sake of the people who use your code. And that is really all you need to know to get started with the case statement. To summarize, the case statement allows us to define a new columns whose values are changing conditional on the other values of my row. This is also called conditional logic, which means that we consider several conditions and then we do have different behaviors based on which condition is true. And the way it works is that in the select statement, when you are mentioning all your columns, you create a new column, which in our case is this one, and you bookend it with a case and an end. And then between those, you write your actual conditions. So every condition starts with a when, is followed by a logical statement, which needs to evaluate to true or false, and then has the keyword then, and then a value. And then the case when statement will go through each of these conditions in turn, and as soon as one of them evaluates to true, it will output the value that you have specified. If none of the conditions evaluate to true, then it will output the value that you specify in the else keyword, and if the else keyword is missing, it will output null. And so this is what you need to use the case statement, and then experience and exercise and coding challenges will teach you when it's the case to use it, pun intended. Now, where does the case statement fit in our logical order of SQL operations? And the short answer is that it is defined here at the step when you are selecting your columns. That's when you can use the case when statement to create a new column that applies your conditional logic. And this is the same as what we've shown in the lecture on SQL calculations. You can use select statement not only to get columns which already exist, but to define new columns based on calculations and logic.